Hi everyone, welcome back to semester 2 of Trig. Today we are going to get started on a brand new section, that is 6.1 section A, that is called Law of Sines. Alright, before we get started, I do want to talk about something that's going to come in handy for you guys for the rest of the semester, and that's right here on the screen. Alright, it's called Trigonometric Identities, that's page 1. Page 2 is a formula sheet. All right, we will refer to this as the golden ticket all semester. This will be something you guys will be allowed to have on every test, maybe every quiz. I can't guarantee that. And then also your final. So the reason for this is if you look very closely at even just page 2, there's quite a bit of information here. All right, and we don't necessarily expect you guys to have everything memorized by the end of the semester. In fact, some of it you might actually get memorized, you might get it down, which is great, but sometimes if we're having brain fog or something, we can revert to this formula sheet, all right? Don't get too worried. A lot of these, honestly, we don't even use, all right? But as we go through the semester, make sure you do have this formula sheet ready and handy throughout all of our classes. We will reference it more often than not, starting today, actually. All right, and once we get into person classes, we will also have printed copies for you guys as well. So if you want to print one out for you right now, that's great. Otherwise, we will make one for you when we see you in person. All right, so to get started, I'm on the second page for this formula sheet. And if you look at number 5 here on the left-hand side, today we are going to be using law of sines. All right, so some things to remember. Capital letters, if you remember your triangles, we're going to be solving more triangles today. Capital letters represent your angles, while lowercase letters will represent your lengths of your triangle, the side lengths. All right, so notice sine A, sine B, and sine C are all in the numerator, while lowercase letters A, B, and C are all in the denominator. All right, there is a pattern there. Make sure you keep to that pattern. But before I get to this and before I just throw this formula at you guys and say, figure it out, memorize it, and what have you, I want you guys to know where they got this from and why law of sines is important. All right, so that's going to take us to the deriving page. All right, and it's not letting me edit this document, so I'm just going to have to show you guys the answers document, and you'll have to just follow along. All right. So why law of sines is important is because now we're going to talk about triangles that are no longer right triangles. So if you remember back in semester 1, before we went on break there, we talked about SOHCAHTOA. And SOHCAHTOA was only useful when we had right triangles. So if you look right at step 1, it says start with triangle ABC, which is not a right triangle. All right, I understand there is a right angle shown in the picture, but if you look at just the bigger triangle, the bigger portion, there is not a right angle on either A, B, or C. So we're working with triangles that are not right triangles. That is why we have to revert to what is called law of sines. All right, just as a rule of thumb, if you do have a right triangle, you can always use SOHCAHTOA. But in this case, we do not have a right triangle, so we are going to introduce law of sines. The beauty of law of sines, though, and the deriving of this and showing you guys how this is developed and how it was made, is the fact that they're going to use SOHCAHTOA. So if you go ahead and follow along with me, I'm going to be on step 1. It says express sine of angle A. Okay, remember your SOHCAHTOA rules. Sine is always opposite over hypotenuse. If you look down at angle A, remember the capital letter, the opposite side, in this case, would be H. I'm looking at that tiny, tiny triangle portion with the right angle. Again, I can't use SOHCAHTOA unless I'm using a right triangle. So I'm looking at just that left-hand side of that triangle with side lengths C and H, and then a little bit of the portion of B. Not the whole B, but the little bit portion. All right, so if I do sine of angle A, I have H over C. My opposite, H, over my hypotenuse, C. Then it tells me that I want to then solve for H. So I'm going to take that function, I'm going to cross multiply that C over, and I get C sine angle A. Same thing for the second one. Now it's asking us to express sine of angle C. Well, this time I'm going to use the right triangle that's on the right-hand side. So my opposite side from angle C is going to be H, while my hypotenuse on that triangle is now A. All right. You can always reference my teacher notes on this too. I go into it a little bit better. Again, I can't edit the document that I have saved on the screen right now. But if you look at my teacher document, you can see the colors and where I'm pulling this information from if you're struggling trying to see those triangles. All right, so please look there if you need. Well, if I have H over A, my next step is to solve for H again. But this case, I want to cross multiply the A over, and that gives me A sine of angle C. Step 2 says use the transitive property, which can be stated that, and again, you're just setting, you see that your H's are the same, or in step 1, our formulas, our equations are both equal to H. Therefore, I can set H equal to H, which now means that C sine of angle A is equal to A sine of angle C. Step 3, they asked us to rewrite step 2 to form a proportion, meaning we want a fraction. So what I did is I put my C's and my A's together. I divided both sides by C while also dividing both sides by A. That way my A's can be together and my C's can be together. That is what step 3 has done for us. And again, if we did cross multiply those back together, we would get the same answer as step 2. All right. Now we're going to do kind of the same thing, but this time we're going to talk about B. So we have step 4. It says now reposition the altitude, so the height of the triangle, and repeat this process. So the height of the triangle, they no longer called H, they now renamed it as K. But we're going to do the same steps. So sine of angle A, again, we're looking at that bottom portion of the triangle. The sine, the opposite side would be K divided by the hypotenuse side, which would be B. Solving for K, cross multiplying over, we get K equals B sine of angle A. Doing the same thing, but this time in reference to angle B, our opposite side is still K, while the hypotenuse this time is A. Again, you're using the triangle on top for that second part there. Also, if you need to see which triangle's which, I have that on my teacher notes for you guys. Solving for K there, you get cross multiplying, you get A sine of angle B. Step 5, very similar to step 2 up above. Use the transitive property. Well, if we know K is equal to something and another K is equal to something else, we can set those both equal to each other. So we got B sine of angle A is equal to A sine of angle B. Rewriting, getting our A's and B's on the same side of each other. So we have sine of angle A divided by A equals sine of angle B divided by B. And last but not least, because of the process of this entire thing, we can now set all of those proportions equal to each other. So that is where the law of sines comes into play. All right. Again, you will have this formula given to you on your formula sheet, your little golden ticket. But I want you guys to understand where this came from and the fact that they did actually use SOHCAHTOA. However, they had to create their own right triangle within a triangle to make it work. All right. Because of this, it now allows us to use the law of sines to start our process. So we're going to get going on our notes, 6.1. All right. And just as a reminder, we are only doing law of sines today because they are not right triangles. So SOHCAHTOA, which you guys have known since semester 1 or even geometry, SOHCAHTOA can only be used with right triangles. And I'm going to just draw a triangle there. All right. That's the only time we can use SOHCAHTOA. So if you never see a right angle, that little box in the corner, or it's not explicitly stated to you, we cannot assume that we are working with right triangles. We now have to assume we're working with an oblique triangle, which is a triangle that does not contain a right angle. So you have two triangles down below that kind of give you that shape. All right. So law of signs is helpful for two reasons. If I were to give you some information, for example, if I gave you SAA, which stands for side, angle, angle, we're allowed to use law of signs, and you will see why. Similarly, if I gave you ASA, which is angle, side, angle, we can also do law of signs. All right. The biggest thing I want you guys to get out of this is that I want you to be able to, whenever you use law of signs, you must have a matching set. What I mean by that is you need to know capital letter A while also knowing lowercase a, or capital letter B, lowercase b, capital letter C, lowercase c. You have to have a matching set in order to use law of signs. If you do not have a matching set, we're going to need to do some rearranging of some stuff and determining information about triangles that we already know. All right. So again, these two formulas here that are shown, it's the same formula, except one just has all your angles on top, while the other one has all your sides on top. Either way, it's the same proportions. And remember, these are on our golden ticket. We do not need to memorize these. So that is some good news for us. All right. When we go to solve these questions, always make sure that we draw the triangle. That will help us in determining some sort of visual representation so that we know what we're given and what we need to find. And if you remember back in semester 1, we used SOHCAHTOA to solve for triangles. Remember, we wanted all 6 pieces of information, all 3 angles and all 3 sides. So we're going to want that same bit of information for these questions as well. All 3 angles, all 3 sides. So to get started on question 1, I'm going to just draw a triangle. All right, it can be any triangle. Obviously not a right triangle because we know we're not working with a 90-degree angle. And I'm going to label it. I always do A in the bottom left. That's just me. As long as you label everything correctly. The A value, the angle they told me was 46 degrees. I'm going to fill that in. C was 63 degrees. And the length of C, remember directly across from the angle, was 56 inches. So now at the end of all of this, I want to know what my angle B is. I want to know what my side length A is. And I also want to know what my side length B is. Those are the 3 missing pieces that I need to know at the end of all of this. All right. So to get started, let's start with the most obvious portion. Okay, we have 2 angles. We're missing the third. Well, if I know I'm working with a triangle, in order to find the third angle, I can take 180 degrees and subtract the 2 angles that I have. Use that calculator if you need it. 180 minus 46 minus 63 will give me a nice 71 degrees. So there we have it. There's our first missing angle, 71 degrees, and that is representing angle B. Now we're going to go into the proportions using law of signs. All right, and remember, we have to have a matching set. So if I were to look at this triangle and I were to say, well, what letter is getting matched? What do I know about both pieces of my letter, or which letter do I know both pieces of? So I want to have a letter that has an angle given to me as well as a side. And so when you look, you will see that C has both. And that's what I'm going to do to determine my function. All right. I'm going to set it up, but this time I'm going to do the C portion first. Again, you can move and manipulate the proportions just by moving them to first, second, or third. Either is fine. So I got sine of C, which is 63 degrees, divided by lowercase c, which was 56. I like to put my angles on top and my side lengths down below. That's just my preference. If you like to reverse it and do sides up top, angles down below, that is fine as well. Just make sure that your angle is sticking with sine every time. All right. Since A is my next one that I want to find here, let's go ahead and solve for A. So I'm going to set it equal to sine of angle A this time, which I do know is 46 degrees. And I'm going to divide it by my side length of A. But I don't know that, so I'm going to just keep it as letter A. Now my proportion is set up. I get to now cross multiply. That gives me A sine of 63 degrees equals, and 56 is going to go out front, 56 sine of 46 degrees. Again, our goal is to solve for A here. So I'm going to divide both sides by sine of 63 degrees. All right, now pay close attention to what happens here. We get A equals 56 sine of 46. That's still staying in the numerator. Now it is getting divided by sine at 63 degrees. All right, just because top and bottom have signs does not mean you get to cross them out. That is not allowed. They are different degree values. They are not the same, so we cannot cross them out. However, we have a calculator that is very handy that can give us our answer. All right, so go ahead and go to your calculator. Again, we are working with degrees here, so make sure your calculator is in degrees. If you don't remember how to do that, that's in mode. Scroll all the way down. Make sure it is highlighted over degree, and you will be good to go. All right, if you want to use that fraction idea, make sure you go second insert, so second delete. Go over to the frac on the right-hand side, and then you should see n divided by d, which will set up a fraction for you. All right. When you do type all of this out, again, remember you are solving for a length, which the directions tell us to round sides to the nearest tenth. So when we solve for A, you are looking for 45.2, and of course, we're talking length here, so we need inches. If it was given in inches, we're going to keep inches. All right. Again, if your calculator is not telling you 45.2, double check. Ask questions if you need. Go back into that call, ask questions. It's probably just set up on the calculator wrong, if anything. All right. So now the last bit of information we need is letter B, lowercase b. Side length b. All right, we can't do the Pythagorean theorem because the Pythagorean theorem is only related to right triangles. However, we can do the exact same thing, except instead of solving for A, we are going to now solve for B. All right, now just like when we did SOHCAHTOA back in semester 1, I want us to only use the matching set we were given from the beginning. So we're still going to use sine 63 divided by 56 because it's still the given information. And now I'm going to set it equal to sine of B, which we found was 71 degrees, over lowercase b. Cross multiply. We get B sine 63 equals 56 sine 71. Divide both sides by sine 63. Again, be very careful. Do not cross out those signs. They are not the same values. Head into the calculator. Again, make sure you are in mode degrees on the calculator because that is in fact what you are plugging in. And when you solve for B, we should get 59.4 inches. And there we have it. All 3 pieces of that triangle that I was missing. Again, if you want to add in the information that we were given, so look, capital A, capital C, and lowercase c, just so you solve all 6 pieces, that is fine as well. That way you know that you have all the information that you needed. Okay. Do you need to have inches written on your side lengths? No, I won't technically be a stickler on that. However, it's not a bad idea. Okay, so if you see units, if you see length measurements, please keep it as a habit, because you will want that habit ingrained as we go through Trig this semester. All right. So let's go ahead and head into question 2. If you guys want to pause this video and try it on your own, by all means, please do so. And then, of course, you can watch the video, see your answers, and see what you get. All right. Do not go into the area one. Just do question 2 on your own. If you want to pause, go ahead and do question 2. All right. So to get started, again, start by drawing the triangle, labeling our angles, A, B, C. Then we're going to label the information they gave us. So angle A was 50 degrees, C was 33.5 degrees, and side length B was 76 inches. All right. Well, if you look closely, they didn't tell us a matching set. We don't have both A's, we don't have both C's, and we don't have both B's. So we're going to have to use some information that we know about triangles to see if we can find a matching piece. All right. So at the end of all of this, I want to know what my side length A is, my side length C is, as well as my angle B. So to get started, let's start with the easiest piece first. We have a triangle. We know that all 3 angles of a triangle have to add up to 180. We already know 2 of those angles, so let's take those out so that we can try to find the 3rd angle. So 180 minus 50 minus 33.5 should give us 96.5 degrees. Well, that, my friends, is our angle B. And now when I add that into my triangle, we now have a matching set. All right, so although they didn't necessarily tell us my angle B right away, it was very quick and simple for us to go in and find what angle B had to be anyways. That is only useful with angles, not so much with sides. So always try to find angles first, so then we can do sides. All right. So now I'm going to solve for side length A, lowercase a. This time I'm going to use my matching pieces, but they aren't going with C, they are going to go with B. So I set it up, sine of angle B, which was 96.5, divided by 76. I want to solve for A, so I'm going to say sine of 50 degrees, divided by lowercase a, which I don't know yet. Following through, cross multiplying. Remember, we get to cross multiply because there is an equal sign separating those fractions. And the numbers that you cross multiply with will go out front of your signs. So A goes out front, and the 76 will also go out front. Divide both sides by sine 96.5. And we get 76 sine of 50 over sine 96.5. All right. Do I need you guys to show all of your work? Again, if you want full points, if you get something wrong and you want us to give you points where points are deserved, we need to see the work. So, show work at your own risk, I suppose. All right. More work, the more points you are able to receive, is what I'm going to tell you there. All right. Especially with this stuff because it gets very technical. So if we go into the calculator, again, make sure that you're separating numerator and denominator. If you're not going to put it in as fractions, make sure you add those extra sets of parentheses around top and bottom. Your calculator can't tell the difference, so make sure you're doing that for it. And our lowercase a value will come out to, again, rounding to the nearest tenth, 58.6 inches. We get to do the same thing for C, keeping the same matching set, 96.5 over 76, but this time I'm going to set it equal to sine of C, which was 33.5, divided by lowercase c, cross multiplying, dividing both sides by sine 96.5, using the calculator, and determining that our C value is going to be 42.2, again, inches. And there is all three of our missing pieces of our triangle. Okay. Keep that calculator handy. Again, keep it in terms of degrees. Make sure it's in degrees mode every time. Any questions, make sure you are asking them. Contact. All right. Now for the last question. We have the area of an oblique triangle. So an area of a triangle in general is 1/2 base times height. But again, we're not talking about a right triangle. We don't necessarily know what the height is in these scenarios. If I look back at this triangle here on question 2, I have no idea what the height was. Therefore, I know I can use a different formula that is also given to me on the golden ticket. So, again, this is on the golden ticket. This is on that formula sheet I showed at the beginning here. So you do not need to memorize that. That's nice for us. The way in which this formula will be used is if I were to give you a question that uses side, angle, side. All right, so if I give you a side, an angle, and then the side as well. Okay? And you can tell that's given by the formula itself. Here's side B, here's side C, and in between both of those sides, we had angle A. So we should know one bit of information from every single letter in order to use this formula. All right. So we're going to still do the same steps that we started with up above. Read the question. It says round to the nearest square meter. We're finding the area, so we want meters squared. It says two side lengths, 24 meters and 10 meters, and an included angle of 62 degrees. Well, we know we're talking about triangles, so let's go ahead and build a triangle. Give myself more room here. So I'm going to say, well, I got triangle, let's redo that. I got triangle ABC. All right. Two side lengths. You can name whatever side lengths as long as they go together. So I'm going to say 24 here, just because. And then the next side length is going to be here. And the key here is it says an included angle of 62 degrees. All right. That doesn't mean that you're going to throw 62 wherever you want. That means that it needs to be included between those two side lengths that you just told me. So that 62 has to go between the two sides you just found. All right. So now take a look at your picture. Again, if your picture matches mine, it's going to be great. If it doesn't match mine, just make sure that angle is set in between those two side lengths that you labeled. All right. So your formula might look a little bit different, but our answer should still be the same at the end. So to get started, take a look at this triangle for me. They gave me a side. The following piece, if I were to keep going here clockwise, then they gave me an angle, and then they gave me another side. So together, I have SAS, exactly what this formula told me I needed to have. So now I can use my formula. Take a look at what what angle they gave us. They gave us angle C, or in terms of my picture, I'm working with angle C. So I'm going to look up above, and I'm going to choose the formula with angle C. And so that means I want to choose this formula here. All right, and actually it's going to be this guy right here. So I want to say 1/2 times side A times side B times sine of angle C. And once I know what formula I'm working with, I can just go ahead and plug in the information. So I got 1/2. My A value, my side A was 24, labeled on my picture. That's where I'm getting it from. My side B was 10, again, labeled from my picture. I'm going to keep sine, and my angle for C was 62 degrees. And once I have this information, I can rely on my calculator. 1/2 times 24 times 10 times sine of 62. Again, make sure you are in degrees. This will give you the answer 105.95. But of course, the directions told us to round to the nearest square meter. So that's going to give me a final answer of 106 meters squared. And there you have it. All right. So your homework tonight is going to be just more practice of the law of sines. Law of cosines will actually be next class. Okay, so just law of sines. Remember, you get these formulas on your golden ticket, on your formula sheet. Use them. The more you work with them, the more you'll actually memorize them. So it won't be too bad. Okay. Any questions, please let me know. Your homework is bookwork tonight. If you don't have your book, we have posted the pages online on Teams as well. So make sure you check those pages if you need them. All right.